Hello Year 7, this is Ms Redmond. I'm doing your PowerPoint for this week, which is all about the night sky. Your normal teacher is going to set you tasks around this work, so you will need a pen and a piece of paper to take notes, and also to do the little mini tasks that I'm going to give you as we go through. The first one of which is to list all of the things that you might be able to see in the sky at night. So if you haven't got your pen and paper, pause the video now and go and find it. And then pause the video and write down all of your ideas for things that you might be able to see in the sky at night. Next question. How many stars do you think you can see at night time? Pause the video again and write down your idea. Here's the answer. It is between 5,000 and 9,000, depending on light levels and how good your eyesight is. So light levels means the light where you are. So if you're in a city or a town, there's lots of street lighting, you won't be able to see that many stars. But if you go out into the countryside where it's nice and dark, there's no interference, you'll be able to see a beautiful starry sky. Alright, so we're going to list through some of the objects that you might see in the night sky. So the closest one to us are artificial satellites. So these are human-made objects that have been placed into orbit around another object. In this case, we're talking about the Earth, and we're talking about all of the different satellites that human beings have put into orbit around the Earth. So the picture on the right-hand side is showing you lots of the different satellites that are in orbit around the Earth now. And the one on the left is the International Space Station, where there are actually human beings living now. And a couple of years ago, 2014, 2016, Tim Peake went up to the International Space Station to do some scientific experiments. You might remember that. The first link on there is to a really short YouTube clip showing you what satellites look like as you observe them from Earth, and it shows 60 SpaceX satellites passing overhead. The second link is to a satellite tracker, so you can actually put in the name of a satellite and that website will show you exactly where it is above the Earth at this moment in time. Alright, orbit, that was a key word used in the previous slide. An orbit is the path of an Earth in space as it moves around another object. Again, we've got a picture of the Earth showing some artificial satellites. The furthest out object, or the one that's closest to you, you can see it in the bottom right hand corner, is a satellite in geostationary orbit. So it orbits around the equator of the Earth, so it's going sort of left to right, east to west, and it stays above the same point on the Earth the entire time. So it orbits at the same rate that the Earth spins, so it keeps in the same position. The other three artificial satellites are all in polar orbits. So their orbits go north to south, or up and down. And as they do that, the Earth spins underneath them, so that eventually they will be able to see every single part of the globe. The next object in space we need to talk about is the Earth. That's the planet that we live on. And as you can see from this photograph, it is most definitely a round, spherical, ball-shaped object and is absolutely not flat. There is no evidence whatsoever for the Earth being flat, because it is not. It's a ball. And in this photo you can see India in the middle, Africa to the left, and in Indonesia and Malaysia off to the right. We're in Europe, which is above Africa, to the left and a little bit up. You can just about make out the boot of Italy. And the link on this slide is to a live view of the Earth from the International Space Station. So you can see what the astronauts on the ISS are seeing right now as they look down on the Earth. It's amazing. All right, the Moon is our nearest neighbour. It is a natural satellite which orbits the Earth. And its light reaches us in 1.3 seconds because it is 384,400 kilometres away. That's slightly misleading that I've written its light reaches us in 1.3 seconds. Have a think about why that's slightly misleading. Pause the video if you want to while you think of your answer. It's misleading because the Moon doesn't produce its own light. We see the Moon because it reflects the light from the Sun. So to talk about its light, the light of the Moon, is slightly wrong because it's sunlight that's being reflected by the Moon. And the link on this video is to a NASA video, which is a tour of the Moon. It's got loads of really detailed information about the Moon. As we've just mentioned, the Moon is a natural satellite. A natural satellite is a natural object, so not made by humans, which orbits another object in space. Natural satellites are also called moons, which is very confusing. So the Moon is our one that orbits the Earth. It's got a capital letter. The other moons have their own names. And the photo on the right-hand side is showing you some of the planets, well, all of the planets in the solar system which have moons with their names. So, for example, Jupiter has the moons Io, Europa, Ganymede, and Callisto. Light years. Light years are a measurement of distance, not time or speed. This is a really important point. 1 light year is the distance that light can travel in 1 year. In kilometres, a light year is 9.46 trillion kilometres. I've written it out there in numbers as well, so you can see just how long that number is. Now, it's really, really difficult to do calculations or even just think about numbers that are that large. So light years are really useful for measuring large distances. For example, Alpha Centauri is 41,311,820,000,000 kilometres away from us. Now, that's difficult to even say. Imagine trying to calculate with that. It's much easier to say that it's 4.367 light years away. The picture on this slide is showing you the distances from the Earth to a couple of different objects in light time. So the Moon is 1.3 light seconds from Earth. The Sun is 8.3 minutes. Alpha Centauri is 4.4 light years away. The Hercules Globular is 25,000 light years away, and the Andromeda Galaxy is 2.5 million light years away. Now imagine trying to do a calculation with those kind of numbers in kilometres. It would be extremely difficult, so that's why we use light years as a measurement of distance. Planets. A planet is a large object which orbits a star. It is spherical, so that means it's big enough that gravity has turned it into a ball. It's not a rocky, knobbly object. It's more or less a ball shape. It's spherical. And it's cleared its orbit. That means that it's big enough that when it's orbiting the sun or a different star, it picks up the debris that's in its path. So it's almost like sweeping a broom across the floor. It picks up the debris as it goes past. A planet must be able to do that. So a good example of something that's no longer a planet is Pluto, because it's now a dwarf planet. That's because it's not spherical and it hasn't cleared its orbit, so it's not big enough, basically. And the link on this slide is to a piece of music called Mars from the Planet Suite. It is absolutely fantastic. It was written between 1914 and 16, but honestly, it sounds so modern, it could be the soundtrack to the latest Star Wars film. It's incredible. There are 5 planets that are visible to the naked eye, and those are Mercury, Venus, Mars, Jupiter, and Saturn. And that photo is showing you what they look like. So they look like stars, but if you observe the night sky, you'll see that they move differently to the stars. There are also planets in other solar systems. So there are other suns in the galaxy and in the universe, and there are planets orbiting around those suns. And this picture is showing you the planets around the Kepler-90 sun. The sun is our sun. It's the star that's at the centre of our solar system. It's a nearly perfect sphere or ball of hot plasma which emits light. Now, plasma is a state of matter that's even hotter than gas. So you take a gas and you heat it up hot enough, you strip the electrons away from the atoms, and you produce ions. You produce like a soup of ions, and that's called plasma. Our sun is made up of 75% hydrogen and 25% helium and small amounts of other elements like oxygen and carbon. And its light takes 8 minutes to reach us, or it's 8 light minutes away. All right, a star. We've just talked about our one. There are lots of stars in the galaxy and in the universe. A star is a ball of gas in space which gives out light, and it's mainly made of hydrogen and helium. The light from the star comes from nuclear fission of hydrogen into helium. So that means that hydrogen nuclei are smashing into each other so hard that they actually join together to form helium, and that is called nuclear fusion. All of the other elements are made from hydrogen and helium smashing together and building up to form those heavier elements. There's a lot of information about stars on the Wikipedia link that I've put onto this slide. It's really interesting stuff. All right, the solar system is a star with all of the objects that orbit around it. So this picture is of our solar system. There are lots and lots of other solar systems. The link on here is to a YouTube video which describes our solar system. A comet is a small object in space, mostly made of ice, which has a very erratic orbit around the sun. So it doesn't have a nice elliptical orbit like the planets do and like asteroids do. It's got a very erratic orbit. And you can see 2 pictures there of comets. The bottom left one is a photograph of a comet, colour photograph, and it's showing the 2 tails. The other photograph on the right is black and white, and it shows it a little bit better because it's got some labels on there. So you can see at the bottom in the middle, there's some arrows saying sun. So that's because the sun produces solar wind, and when that solar wind hits the comet, it actually blasts off some of that material and turns it into a gas, and that produces the gas tail that you can see spreading out next to that comet. So the gas tail always forms in the opposite direction to the sun, or it forms with the solar wind. Now, the other tail that you can see is called the dust tail. As the comet travels, it throws off little bits of dust. However, that dust tail is deflected by the solar wind. So you can see the line with the arrow that says dust trail. That's the direction that the comet's travelling in. So the dust tail would be along that line, but it's been blasted. It's been deflected by the solar winds, and so that's why it's more in line with the gas tail. And then the link on this slide is to an episode of The Sky at Night about how to catch a comet, which is all about the Rosetta mission to land on a comet. Even if you just watch the first couple of minutes, it's got some really interesting information about comets. Meteors, etc. This is where it gets a little bit confusing because there's lots of similar words going on here. So the two that are most important for you are in bold. They're meteors and meteorites. A meteor is also called a shooting star. So you might have seen one if you've been out watching the night sky, maybe out in the countryside where there's not lots of light pollution. It is a small rocky or metallic object from outer space which reaches the Earth's atmosphere. So that's the key feature of a meteor, that it reaches our atmosphere and we can see it. A meteoroid is a small rocky or metallic object travelling in outer space, so it doesn't reach the Earth's atmosphere. A micrometeoroid or space dust is a very, very small rocky object travelling in outer space. So it's an extremely small meteoroid. A meteorite is a small rocky or metallic object that lands on the Earth's surface. So I find that confusing because normally "ite" means something that's smaller. So I would have thought a meteorite is a small meteor, but it isn't. It means one that's landed on the surface of the Earth. And then an asteroid or a minor planet or a planetoid is a small rocky object orbiting the sun. So it's not a comet because it doesn't have an erratic orbit. It's got a fairly elliptical orbit. So that's why we have the asteroid belt made up of lots of small rocky objects all orbiting the sun. A galaxy is a huge collection of gas, dust and stars held together by gravity. And you've got some examples of galaxies in that picture there. The link that I've given you is to Zooniverse, and this carries out citizen science projects. And they used to have one about recognising the shapes of galaxies, but they must have finished that one and they've replaced it with variable stars. It's really interesting. A citizen science project relies on members of the public getting involved with scientific projects, as it says. For this particular one, it's taking advantage of the fact that human beings are very, very good at spotting patterns, even better than computers. So you can log in there and it will give you instructions for how you can help their variable star project. The Milky Way is our galaxy. The left-hand picture is a photograph of the Milky Way taken from Earth, and the right-hand picture is an artist's impression of the Milky Way galaxy, which is a spiral galaxy, and they've labelled up some of the spiral arms. And in the middle, at the bottom, you can see a little label that says Sun. That's where we are in our solar system, on the Orion spur of the Milky Way galaxy. The universe is all of space and time and their contents, including planets, stars, galaxy, and all matter and energy. So essentially, everything. All right, your next task is to put the following objects in order of size, please. Grab your pen and paper, pause the video and write down those things in order of size from biggest to smallest, biggest at the top. And on the next slide, I will show you the answer. All right, those objects in order of size are the universe. Of course, it's the biggest. It's everything. Then you've got the Milky Way, which is a galaxy, the solar system, which is in the Milky Way galaxy, the sun, which means our sun. Jupiter is a gas giant. Then we've got the Earth, which is a terrestrial planet or a rocky planet. Then we've got an asteroid, and then a meteor. And your last task for this lesson, please, is to answer the question, what jobs might use the information in this lesson? So stop the video or just let it run to the end. Write your ideas of what jobs might use the information in this lesson, please.